do you test a fire alarm panel whether it is working or not? No. See, you get a panel, brand new panel. No, there is no test lamp in the panel. How do you? Yes, put end of line in the panel. Correct? How do you check? Without removing all the field devices, you put the end of line in the panel and it should show everything okay. That is the way to find it out. That is how you remove the wire and put the end of line in the panel. Correct? So, anyway, how does it gives, see, anytime it has got a voltage drop and some other problem, 24 volt is still there, then it gives you a fault. How do you get a fire? Fire ഉണ്ടാവുക എങ്ങനെയായിരിക്കും? Circuit short out. Some panels it is like that. Some panels positive negative, but not all the panels. So there is a way it is programmed that some kind of changes here will notify the panel it is fire. Some kind of changes will notify it is
voltage drop on.
Voltage drop on. That depends. എല്ലാ പാനലിനും ഫയർ ഉണ്ടാവുന്ന ഓരോ പോയിന്റ് ഓരോ ഇതിലാണ്. ഇവിടെ വേറെ ഫയർ ഇല്ലേ? അപ്പൊ ആ പാനൽ പ്രോഗ്രാം ചെയ്തിട്ടുള്ളത് 20 ohms വരുവാണെങ്കിൽ അത് ഫയറാണ്. അതിനകത്ത് ഷോർട്ട് ആക്കല്ല, ഒരു റെസിസ്റ്റൻസ് ഇട്ട് കൊടുക്കണം. ആ ഷോർട്ട് ആക്കി കഴിഞ്ഞാൽ ആകെ അടിച്ചു. അപ്പൊ ഒരു 20 ohms ഇട്ട് കൊടുത്തു കഴിഞ്ഞാൽ അതിന് മനസ്സിലാവും അത് ഫയറാണ്. റെസിസ്റ്റൻസ് സംസാരിച്ചില്ല. എവരിബഡി നോ വാട്ട് ഈസ് റെസിസ്റ്റൻസ്. ഇറ്റ് ഈസ് ടു റെഡ്യൂസ് ദ ഇലക്ട്രിസിറ്റി. ഒരു റെസിസ്റ്റൻസ് നമ്മൾ ഇങ്ങനെ theoretically കാണിച്ചാലും a resistance looks like this. Okay, it has got a golden or a silver line at the top. Yeah, codes. And there will be color bands here. I don't remember the colors. Red, yellow, orange again.
Yeah, BBR, very good voice.
BBR. And that is silver into 100, into 500 or 1000. Gold lining are into 500, something like that. That way you can.
Gold divided by.
What is the
value of the resistance? You know, to find out the value of the resistance, like electronics people should be experts in that. I forgot all this. I learned, but forgot. So this is how you write the value of this one. And this EOL end of line will be programmed such a way that it will reduce the voltage to 12 volt. So because it is inside the break glass, and if you break the glass, this resistance is here, and the value is 12 volt. Correct? Then it goes fire. അങ്ങനെ ഒരു ടെക്നിക്കൽ സിസ്റ്റം ഇത്ര ഡീപ്പായിട്ട് എനിക്ക് പറയാനറിയില്ല. ബട്ട് ഫീൽഡ് പീപ്പിളിൻ്റെ അടുത്ത് ഈ ഒരു ക്വസ്റ്റ്യൻ എന്തായാലും ചോദിക്കും. യു ഹാവ് ടു സ്റ്റഡി ദാറ്റ്. ഇൻ ഈച്ച് ഫയർ അലാം പാനൽ വാട്ട് ഈസ് ദ വർക്കിംഗ് പ്രിൻസിപ്പിൾ ഓഫ് റെസിസ്റ്റൻസ് ആൻഡ് ഹൗ ഇറ്റ് ഈസ് എഫക്റ്റിംഗ് ദി യെല്ലോ ആൻഡ് ദ ഫോൾട്ട് ആൻഡ് ഫയർ. ദിസ് ഈസ് എ ഷുവർ ക്വസ്റ്റ്യൻ ഫോർ ഫീൽഡ് ക്വസ്റ്റ്യൻ. യു ഹാവ് ടു ലേൺ ഫ്രം ദി ബുക്സ്. അത് ഇന്റർനെറ്റ് നോക്കി പഠിക്കാം. Okay, and along with this, you will have a separate line for the bell. Correct? It is separate line. And design parameters nu parayanengil, like zoning il oru design parameter undu. I mean, I am not getting into design parameters. I am not a design engineer, but still not all the people has to know the design parameters. The zoning in the terms and conditions and FPA code and the standards and the etra zone aayittu thirikkanam. That's a design parameter. The number of detectors in a loop is depending on, in a zone depending on the manufacturer recommendation, and 20 to 24 is the generally used one. Other design parameter alla endayirum design parameter aakki parayam. Pinne bellinte separate line എത്ര ബെല്ല് ഒരു മാക്സിമം ലൈനിൽ വയ്ക്കാൻ പറ്റും. ഇങ്ങനത്തെ കുറെ ഡിസൈൻ പാരാമീറ്റേഴ്സ് ഉണ്ടാകും. ഓരോ പാനലിനും കുറെ ജനറൽ ആയിട്ട് കുറെ കാര്യങ്ങളുണ്ടാവും. ഈ റേഞ്ച് തരും 20 to 24 ഈ പറഞ്ഞ പോലെ. So the value you have to get the information from the books, and you have to teach the others, because I am not a professional to do that. I am not an electronics engineer or something. Okay. Now, so conventional panel, I can close it here. Any doubts on conventional? As with my knowledge, that's it. Okay. Now it's getting 12:30, 12:35. If somebody wants to go for prayer, they can go. We'll continue. You can come back. Now conventional we've done. Now we have addressable. What is the main difference between conventional system and addressable system? First and the foremost one, each device has got an address. Okay. second important thing that an electrician should know. What is it? Yes. Now end of line, the circuit completed by going and coming back to the panel with the field devices. Sorry? Those I will come in. That are all the design parameters in installation side. I'm just taking about this one. So the main difference is that each device has got an address and the loop should be completed for the installation to complete. Okay? So this is the main difference between conventional system and addressable system. Now, normally we should use fire protection cables for all the both the devices to connect it. Fire protection. Earlier days, initially the fire protective systems cables were used as MICC. Anybody work with MICC? Huh? They have not worked. Huh? Yeah, insulated copper tubes, copper cables. This was the original one, which is the wire running within the white powder, non-conducting powder, and 2 wires line. This is very expensive. Okay, very difficult to use because each joint has to be in a gland. Okay, so this is almost obsolete and nobody is using it until and unless it is in ship or something, wherever it's must. I mean, so not a must, but still oil field areas, where the specification is very high. But fault finding with the MICC is very difficult. And in addressable system, if you have a small leakage, it shows fault, which you cannot have rectified with the MICC. In addressable system, if you start using a MICC cable, you will never have a problem ending. So people, they have developed a wire called FP200, okay, which is again fire protected, which will run for how many? 1 hour, I believe. 1 hour fire protected, right? See, these values I am not quite sure. Yeah, it's 1 hour, correct. 1 hour is the capacity that it should resist fire. During fire. Okay, that is the MICC FP200 cable. Now, this is the type of cable, but what is the thickness? The normal available thickness what we use in fire alarm is 1.5 and 2.5 mm per square. 1.5 mm is used for the signaling devices such as heat detector, smoke detector, and break glass. These are all called signaling devices. 1.5 mm is used for this one. Whereas 2.5 mm is used for the bell circuit because it has got more current. Ampere is more here. Okay, so that is used in fire alarm system for bell circuits. Okay, now in the fire alarm panel, both conventional and addressable, there is a power supply unit, but there is battery backup. Okay, these batteries are normally 12 volt each, so it is connected in each battery is 12 volt. It is connected series. Because only in series you will get 12 plus 12. If it is in parallel, you will get only 12 volt. So this is connected in series. This is series, right? This is connected in series and it has got a backup. This battery backup, normally now we use is lead acid, sealed battery, which should give you minimum 30 minutes of working in case of no power. An important point you have to notice, the battery duration, the capacity of the battery is to run the panel with the devices for minimum 30 minutes without the main power supply. So in case of fire, if the power breaks here, the system should work, complete system should work at least 30 minutes without interruption. Okay, now regarding the sensor, I told you there is spark sensor, Okay, smoke sensor, heat beam sensor. Okay, but see, I mean, there are too many things. If we elaborate, we don't have time. See, a simple working principle of smoke detector. Okay, there is two types of again smoke detector: ionization. Okay, then phototype. Okay, what is the difference between ionization and phototype? No. What is the difference? How? Why? What is the working principle of ionization? What is the working principle of phototype? So you have to learn. Where you use ionization, where you use photoelectric. See, you have to master your field. Otherwise, you will be in trouble. You have to read your books. You are educated. You have to Google it, find out the answers. You have to read. Ionization has got an ionization chamber inside. If the smoke, due to a fire, definitely there is smoke. Smoke goes there. Smoke has got charged particles inside, which is either positive or negative. Smoke is always with charged particles. It goes to the chamber. When the charged particle goes there, the chamber detects that there is charged particles and it gives a sign of fire. This is the working principle of ionization smoke detector. Photoelectric is not that. It is a light sensor inside, which will detect again charged particles. But ionization is the commonly used before. Now we've been getting to photoelectric type because lot of dust going inside and this will keep activated. That is why we are changing this one. Now coming back to detectors are over. I told you different types of sensors that we have, spark sensor, video, there is video sensor, you know, video will detect smoke. Lot of sensors, spark sensor, then lot of sensors are there. You know, multi-sensors are there, which will have, take you heat and smoke together. So lot of sensors are there, we have to take time to understand that. Okay, now, regarding the loop I told you, no, in addressable. Now, zoning side is more of a design. I don't want to get into that. Okay, now one of the common questions that is being asked for the technical side. What is the height of the brake glove that you fit? See, always you say FFL. What is that? Finished floor level. Always this measure is from the finished floor level. What is the height of brake glove from finished floor level?
2.5. 2.5 meter. 1.37.
I will get the exact value. It is 1.2. 1.2 plus or minus 20. You can go 1.2 plus 20 or minus 20. But this is the value. 1.2 is the value, I believe. I'll just get back to you that on that one because I have to refer that. I don't write it here. Anyway.
Maximum 1.4.
Yeah, maximum 1.4. That's what I 1.2 plus or minus 20 is good. Similarly, you have bell. Okay, from finished floor level, FFL. What is the height of the bell to the bottom?
2.75.
2 point?
75.
No, it's too high.
2.5.
No. You guys are installation technical people, you are getting it 2.75?
It's 2.5.
No, it's 2.1. Plus or minus 20. From finished floor level, you should. Technically speaking, you are wrong because floor level sound test. So the bell is designed to keep it at 2.1 plus or minus 20. Whether the floor level, what is the sound you are getting? So these are the basic things that you have to understand, especially the technical people. The drawing measurement, but people who are installing this should have to know these values. Some sample questions will be given to you. You have to refer to that and make sure that you cover all those things. Okay. So this and spacing between the detectors. See, spacing between the detector. What is the spacing between the detector? Of course, refer to the manual. Refer to the manual. This answer product refer to the manual. Manufacturer recommendations anybody can say. But what is the spacing? What is the maximum? What is the area covered of detectors?
7 meters.
See, we can have detector 1 meter, 2 meter, any gap. Less. The more closer it is, more safe. But what is the standard? That is the question.
81 meters square.
81? That is when it is meter square, it is area. I'm asking you the distance between a detector to detector, center to center. That is how you say, always say center to center.
9 meters.
8 meters.
6 meters. 6 meters.
Forget it. Center to center, maximum you can have 10 meters. Maximum. Generally, most of the people, the manufacturers, 8 to 9 meters maximum they allow, and they placed at 8 center to center. But 4 detectors when connected, it should not go more than 80 square meter in a room. 4 detectors will cover loop this area, okay? They will cover that area. Maximum is 80 square meter. You have to learn these things. And manufacturer will 80 you can go up to 9. But this is the maximum allowed by NFP. Not more than that. 80 square meter is the maximum area that you can consider here also. Okay. Now, suppose you are in a room. Okay. Where you start the first detector? Technical installation people. Where you start the first detector? If you have not designed or something, yeah, tell me.
From wall to 4 meter first.
Sorry?
From the wall to 4 meter first.
No, it's not 4 meter. See, now you do drawing. You do design aspect. You do drawing upward simply with the drawing and go to measurement fix. But you need to know. First and the foremost thing, what is the distance here? But it is more than 10 meter. Definitely go for 2 smoke detector. Correct? If it is more than 10 meter, you have to go for more than 2 meters. Suppose this is 20. Okay? This is 30. Okay? The first detector, how you start? It should be 2.5 to 3.5 if it is a smoke. Correct? This is maximum allowed is 3.5 meter. Now this distance can be reduced because ഇവിടെ 3.5 ഇവിടെ നമ്മൾ 3.5 നമ്മൾ വെച്ചിരിക്കും. Okay? അപ്പോൾ എത്ര 7 മീറ്റർ പോയി ആകെ 20 ആണ്. അല്ലേ? അപ്പോൾ 7 മീറ്റർ അപ്പോൾ ഇത് 13 മീറ്റർ ആണ്. 1 ഡിറ്റക്ടർ വെച്ചാൽ മതിയാവോ? പറ. ഇവിടെ ഡിറ്റക്ടർ വെച്ചാൽ ശരിയാവോ? മതിയാവോ? ഇല്ല ഞാൻ ചോദിക്കുന്നത് സി 20 മീറ്റർ ആണ് ആകെ ഹോള്. ഇത് 3.5 മീറ്റർ ഇവിടെ പോയി ഇവിടെ 3.5 മീറ്റർ പോയി. ബാക്കി 13 മീറ്റർ ഉണ്ട്. ഞാൻ ഇവിടെ ഡിവൈസ് വെച്ചാൽ അത് മതിയാവോ? എന്താ?
10 കൂടുതലായി.
ഏതിന് 10 കൂടുതലോ? എവിടെ 10 കൂടിയേക്കണം? എവിടെ 13 മീറ്റർ ആയിട്ട് ഡിസ്റ്റൻസ് ഇതാണ് 13 മീറ്റർ.
7 meters.
അല്ലേ? Look at the drawing. എവിടെയാണ് അവിടെ 13 മീറ്റർ വരുന്നത്? From this point to this point. What is the rule say? It should not exceed 10 meters from detector to detector. But I am putting one detector here. Then what's your problem? Then what is the distance? 6.5? 6.5. Are you safe? Not safe. അപ്പോൾ നമ്മൾ എന്ത് ചെയ്യും? 6.5 6.5 വയ്ക്കുമ്പോൾ നമ്മളിവിടെ 3.5 മീറ്റർ നമ്മൾ 2 വയ്ക്കും. ഇവിടെ ഒരു 2 വയ്ക്കും. ബാക്കി അപ്പോൾ 2 4 പോയി 20 16 ഉണ്ട്. ഇവിടെ ഒരു 8 മീറ്റർ വയ്ക്കും. കണ്ടോ? Understand how I went from here to here? ഇപ്പൊ 2 മീറ്റർ ഇവിടെ നമുക്ക് 3.5 മാക്സിമം ഉണ്ട്. We are safe here. വേണമെങ്കിൽ 2.5 വയ്ക്കാം. അപ്പോൾ ഇവിടെ 7 മീറ്റർ വയ്ക്കാം. ഇനി ഇതിന്റെ ഡെപ്ത് ഓഫ് ഡിസൈനിങ്ങിലേക്ക് എനിക്ക് പോകാൻ പറ്റില്ല. വാസ്റ്റ് സബ്ജക്ട് അത് മാത്രമല്ല ഞാനൊരു മാസ്റ്ററും അല്ല. പക്ഷെ ഡിപ്പെൻഡിങ് ഓൺ വേരിയസ് കണ്ടീഷൻസ് വി ഹാവ് ടു പ്ലേ അറൗണ്ട്. ഇപ്പൊ ഇവിടെ വെച്ചു. ഇനി ഇവിടുന്ന് ഇനി ഇങ്ങോട്ട് നമ്മൾ കാൽക്കുലേറ്റ് ചെയ്യണം വേണ്ടു വേണ്ടേ? ഇവിടെ നമ്മൾ ഇത്ര ഡിറ്റക്ടറിലായിട്ടുള്ളൂ. ഇത് ഡിറ്റക്ടർ വെച്ചപ്പോൾ ക്ലിയർ ആയില്ലേ? ഓക്കെ. നൗ ഈ റൂം 30 മീറ്റർ ആണ് അല്ലേ? Another 2.5 or 3.5. ഒരു ഡിറ്റക്ടറിലൂടെ. ഓക്കെ. ഇവിടെ എത്ര ഡിറ്റക്ടർ വയ്ക്കണം? You have to understand. ഇത് എത്ര ഡിസ്റ്റൻസ്? 3.5. ഇത് എത്രയാണ്? 3.5. എത്ര പോയി? 7. What is the balance distance?
23.
23. എത്ര ഇട്ട് വെക്കണം? 2. Correct? 23 divided by 3 വരും അത്. ഒരു 7 point something വരും, 7 point something വരും, 7 point something വരും. You got it? This is how you design a fire alarm system. അപ്പോൾ നമുക്ക് ഇത് ഓരോ സ്റ്റാൻഡേർഡ്സ് ഇവർ പറയുന്നുണ്ട്. ദിസ് ഈസ് ദ മാക്സിമം, ദിസ് ഈസ് ദ മിനിമം. അങ്ങനെ ഓരോ സ്ഥലത്തിനും ഓരോ ക്രൈറ്റീരിയ ഉണ്ട്. അത് മനസ്സിൽ വെച്ചുകൊണ്ട് യു ഹാവ് ടു ഡിസൈൻ ദ റെസ്റ്റ് ഓഫ് ദ സിസ്റ്റം ആൻഡ് ഡിപ്പെൻഡിങ് ഓൺ ദ റൂം. ഇനിയിപ്പോൾ ഞാൻ വളരെ ചെറിയ റൂം ആണെങ്കിൽ ഇറ്റ് ഇസ് എ മസ്റ്റ് ദാറ്റ് യു ഹാവ് ടു ഹാവ് എ ഡിറ്റക്ടർ. ഇറ്റ് ഷുഡ് ബി ദ സെന്റർ, നോ ഡൗട്ട് അബൌട്ട് ഇറ്റ്. ഇപ്പോൾ 5 meter by 5 meter റൂമാണ്. The only position that you can put a detector is here, nowhere else. You should not put it here or here or here or here. It is understood that it should be the center. Any doubts here? Okay. നമ്മളിനി ഫയർ ലാമ്പിനെ കുറിച്ച് സംസാരിക്കാത്ത വല്ല പോയിന്റുകളുണ്ടോ? Anything I didn't talk about fire lamp? We talked about cable, detectors, working principle, design parameters. Okay. Now, distance between the break glass. By technically speaking, they say 40 meter.